In this video, I discuss the general layout of hydraulic systems or component used in a hydraulic systems. So in a hydraulic systems, the various components are used. The basic hydraulic system has the following components. First component is the oil reservoirs. So here we go with the animation so you can easily understand it. So it is the oil reservoirs in which the oil are stored. Okay. Second component is the rotary pumps. So pump is located here and the pump is runs by using this electric motor. So here the M is written and this is the shaft. Okay. So this shaft is transmit the power from motor to pump. The pump take the oil from the oil reservoirs, increases pressures, and then it is supplied to the direction controls valve. Third component is the pressure relief valve. So pressure relief valve is generally installed at the outlet of the pump because it is generally used for the control the pressure. Okay. So it is installed here, that is called as the pressure relief valve. Fourth one is the direction control valve. So we understand these all the components in the detail later on. First we see the what are the various components. So just we make the list. So here you see it is a 4x2 direction control valves. So it is a 4x2 control valve, means that is a 2 inlet and 2 outlet is there. Total 4 valve is there. Okay. So this is one inlet that is coming out from the pump. It is the P and it have the 2 outlets. Okay. It is either supplied to this A pipe or either supplied to the B pipe. That's why its name is the 4x2 direction control valve. Then after next is the flow control valve. So flow control valve is provided here. Okay. So here you see it is the flow control valve. Then next component is the double acting cylinder. Here you see it is the double acting cylinder. So why its name is double acting? Because inside the cylinder, here you see this yellow color component is the piston and the oil is supplying both the side of the piston. That's why it is called as the double acting cylinders. So oil is either supply A sides and the B side. Okay. Or it is supplied on both the sides. Next component is the pressure gauge. So pressure gauge is also installed at the outlet of the pump. So here you see it is the pressure gauge. And the last component is the filter. So here you see this is a 4x2 control valve. Okay, so here the 4 valve is provided and its name is the T. Then this oil return is supplied to this filter here. Okay, so this component name is the filter. Okay, in a some book the filter is provided at the inlet of the pump. Okay, in a some book it is provided at the outlet of the pumps. Sorry, not outlet, but it is at the return pipes. Okay, so if you see the filter here at the inlet of the pump, this is also the correct. Now we understand all the component in the details. First component is the oil reservoirs. Okay, so here in this image you see at the bottom the oil reservoir is provided. So main functions of the oil reservoir is to store sufficient amount of the hydraulic oil in the system. Means it is generally used for the storage of the oils. Okay, in a bike or car what we are doing, we are store the petrol or diesels in our car tanks. So similarly it is the one of the storage place for the oil, because in a hydraulic systems we know that the liquid is used and generally we are use the oil as a liquids. Okay, and in pneumatic systems we use the air. Apart from this, it has the another important function, such as means apart from the store of the oil, they have also some another functions. First one is to control the hot return oils. Here you see these are the return oil is coming. So return oil temperature is increased in this various part or various components, because in a pump its pressure is increased. So with this pressure its temperature is also increased due to the friction in these different pipes and then different component, its temperature is also increased. So return oil temperature is higher, so its temperature reduction is also required and it is carried out in the oil reservoirs. Next function is to settle down the contaminants. So due to the wear and tear, some of the parts are wear out. Okay, so this metal part is coming out with the oils. Okay, so we need to remove this part. It is called as the remove or settle down the contaminants. To remove the air bubbles. Why the air bubble is created in a oil? So when the temperature of the oil is increased, So by default there is possibility of the bubble is created inside the oils. So we need to remove these oil bubbles or air bubbles from the system. Next point is to separate the water from the oil. So it is also carried out in the oil reservoirs. Now before moving ahead, I request to like the video and subscribe my channels for watching the more video related to oil hydraulics and pneumatics and other subject of the mechanical engineerings. For the more video, I request to visit the playlist. Second component is the rotary pump. Okay. So why the rotary pump is required? In a oil hydraulic system, we require to increase the pressure. Okay. Without increasing the pressure, oil are not able to create the much force. Okay. So if we increase the pressure, then the force is increased. Okay. The functions of the rotary pump is to pump hydraulic oil to the hydraulic circuits. Means pump is suction the oil from the oil reservoirs, increase its pressures, and this high pressure oil is supplied to this hydraulic circuit. Okay. So these all the part is known as the hydraulic circuit. Means this pressurized oil is supplied to direction control valve, then flow control valves and double acting cylinders. Okay. So this part is called as the hydraulic circuit. It converts the mechanical energy into a hydraulic energy. Okay. So mechanical energy means it is the rotation of the shaft. Okay. So in a pump, here you see it is the shaft. Okay. And the shaft is rotated, it is called as the mechanical energy. So how we create the mechanical energy? So we have generally available electrical energy. Okay. So what we are doing, we supply the electrical energy to the motor. So motor converts electrical energy into the mechanical energy, and this mechanical energy is supplied by the shaft to the pump, and pump is convert this mechanical energy into the hydraulic energy. Rotary pump is a positive displacement pump. Okay, so that is a various type of pump is available. So, okay, so it is not necessary to use the rotary pump in hydraulic systems. You are able to use also another type of the pump. Okay, but in this image we discussing about the rotary pump is the positive displacement pump, and it can deliver the constant flow even at the high pressure. So rotary pump is delivered at the oil at the constant flow even at the higher pressures. Third component is the pressure relief valve. So if you understand this meaning of word, that is a pressure relief valve. Relief means reducing some work. It is called as the relief. Now here with the relief pressure word is used. So pressure relief valve is used to reduce the pressure of the oil. So it is an important component which is required for every positive displacement pump. Okay. So here you see that pressure relief valve is attached with this outlet of the pump. Okay. This valve is connected at the outlet of the pump, and its main function is to release the oil back to the tank when the pressure is increased behind the preset value. Suppose we are required a 10 bar pressures in our hydraulic circuit. Okay. But due to some circumstances, the pump is delivered the oil at a 12 bar pressure. Okay. But what is our desired pressure is the 10 bar. Okay. So what we are doing for this pressure is reduced by using this pressure relief valve. Okay. So first the pressure is measured by using this pressure gauge. Okay. It is the pressure is the about 10 whatever the require. Okay. So we require 10 and the pressure is the 12 bar. Then what happened? The pressure gauge is give sense to the pressure relief valve, and the pressure relief valve take the some quantity of the oil back and supplying to the oil reservoirs. That's where the pressure at the outlet of the pump is reduced with 12 bar to 10 bar. Next is the direction control valve. So from this name you can also understand what is the meaning of direction control valve. It change the directions of the oil or guide the oil in a proper directions. Okay, you are going in these directions, you are going into these directions. Okay, so oil is the direction control valve suggests to oil to move in these directions. Okay, so it is not necessary that the oil coming out from the pump is only supplied to the one single systems. Okay, so here you see we use the double acting cylinder, so we require to supply the oil in two directions, either through the pipe A or either through the pipe B. Okay, so how the oil is going, for that we decide by using the direction control valve. Okay, so sometime oil is supplied through pipe A, sometime oil is supplied through pipe B. Okay, So it controls the direction of flow of oil by which it performs extensions and retractions of the actuators. Next component is the flow control valve. Okay, here you see this is the flow control valve. So from its name we also understand it's control the flow. That's why its name is the flow control valve. What is the meaning of flow control? Flow means it's control the quantity of the oil supply to this cylinder. Okay, this cylinder is one type of the actuator that we understand in the next points. Okay, so sometimes the oil supply to the cylinder is required at 2 meter cube per minute. Sometimes 2 liter per minute. Sometimes it's required 2.5 liters. Sometimes it's required 3, 4 or 5 liters. So it is controlled by using the flow control valve depending on the pressure or a force required. So it controls the rate of flow of oil by which speed of extensions or retractions of actuator is controlled. This actuator means it is a double acting cylinder, so you not need to confuse. Next part is the actuators. Actuators produce the work. Okay, what is the work? Work means it's produce some mechanical work. Okay, and what we supply energy to these actuators. Okay, so this double acting cylinder is our actuators in which we supply the hydraulic energy. Okay, so what happen in actuators? Hydraulic energy is converted into the mechanical energy. Okay, and here in the pump what happened? We supplied the mechanical energy and it is converted in hydraulic energy. Okay, so what is our system is that we take the oil from here, that is the hydraulic energy, and we here get this mechanical energy. Okay, and in a pump we supply mechanical energy and here get we mechanical energy. So some person is think that directly we supply this mechanical energy here. Okay, why we are required this much of the systems? So for that you comment on this video what is the answer. Okay, why we supply mechanical energy as an input to the pump and we also get the mechanical energy in the output. There are two types of the actuators. One is the linear actuators and the second is the rotary actuators. Linear actuator is called as the cylinder. Okay, so here you read this word, that is double acting cylinder. So this is our linear actuators, and the rotary actuator is called as the motor. Okay, so in the next few chapters you hear this word actuators, what are the various types of actuators. So hydraulic motor is also there. Okay, you only hear the name is that is electric motor is there. Okay, but hydraulic motor word is also coming in a few chapters. Okay, so what is the meaning of hydraulic motors? It is the rotary actuators. Okay, so rotary actuators is also called as the hydraulic motor. Double acting cylinders develop the force and motions. Okay, so here we supply some quantity of the oil and it's converted into these mechanical motions. Okay, so this piston is reciprocate. With this piston, this connecting rod is also reciprocate, and here some force is created. So how amount of the force is convert? So it have the equations. Which equation? Force developed is equal to pressure of oil and is equal to force developed is equal to pressure of oil into area of the pistons. Okay, so here we see that the force developed is directly proportional to the pressure and the area. Okay, so if we increase the area, force is increased. If we increase the pressure of oil, the force is increased. Okay, so we are going to increasing the pressure of the oil, we are able to achieve the more force. Okay, suppose we require more force, we have only one option to increase the pressure of the oil. Because the area of the piston is fixed, we are not going to change the area of the piston. Okay, because it is a fixed component is there. So we have only one option is that if we want the more force, we increase the pressure of the oil that's supplied to the actuators. Okay, and in actuators the hydraulic energy into the mechanical energy. Okay, means we supply hydraulic energy into actuators and it is converted into the mechanical energy. Next component is the pressure gauge. So you already know what is the function of pressure gauge. It is an important component of hydraulic system. It shows the pressure reading. Okay, why it is important? We are not only written it is important. Okay, it have some reasons that why we written it is an important components. Because without measuring the pressure relief valve is not operate. Okay, and if the pressure is increased, then then are also chances of the collapsing of the systems or damage or leakage is created inside the system. So it is most important thing is to maintain the pressure inside the any hydraulic systems. So pressure settings are made by locking to the pressure gauge. Without pressure gauge, it is not possible to make the pressure relief valve setting and unloading the valve settings. Okay, so without pressure gauge, the pressure relief valve is not operate. Okay, because pressure relief valve is required to sensing of the pressure, and this sensing is done by using the pressure gauge. That's why this pressure gauge is most important. And the last component is the filter. Main function is to remove suspended solid contaminants from the oil and to provide clean hydraulic oil to the systems. Means the filter is generally used to remove the suspended solid contaminants from the oil and supply the clean oil to the systems. So in some book the filter is provided in this return pipe, and in some book it is put in a supply pipe of the pump. Okay, so both the locations are correct. You not need to confuse about it. So thank you for watching this video. If you learned and liked the video, subscribe the channel, comment on the video, and don't forget to share with your friends.